Hi everyone, my name is Sanjay Chouhan and welcome to my YouTube channel. So in this NLP series, currently we are discussing deep learning for NLP, and in deep learning for NLP we have discussed LSTM and RNN, and we have also done a case study using LSTM and RNN. Now in this video we'll discuss encoder-decoder model. So the encoder-decoder model is also a deep learning model for NLP, and it's a sequence to sequence model. Basically, we'll have a text sequence as input and the output is going to be a also text sequence. We have seen a glimpse of encoder-decoder model when we saw types of RNN models. There we saw many to many RNN model of different length. So when we have different length input and different length output in many to many RNN, we get an encoder-decoder model. So that's the basic idea of encoder-decoder model. We'll go deep into encoder-decoder model in this video. Uh, we don't have to use RNN only. We can also use LSTM and GRU units in encoder-decoder model. And in this video, I'll be using LSTM unit for explanations. The encoder-decoder model are mainly used for machine translation, question answering, and summarization kind of task, where the input is a text sequence and output is also a text sequence. And the input output can be of different length. So let's dive into the explanations. The encoder-decoder model has basically three components. The first one is the encoder, and we have decoder, and we have the internal state. Okay, the internal state is also known as context vector or intermediate vector. We provide the input to the encoder. So we feed the input to the encoder, and the encoder produces context vector. The context vector is a representation of the input. So it's a high-level representation of the input. You can think of it as a summary of the input. And then we provide this context vector as input to the decoder, and decoder produces the output. So the flow is input is provided to the encoder, encoder produces context vector is provided to decoder, which produces output. The encoder and decoder are basically RNN or LSTM or GREs. So we'll see the encoder-decoder model using LSTM unit. Similar thing can be done using the RNN unit as well. But in this example, I'm showing the LSTM unit. So remember in the LSTM unit, we had two vectors. One was the cell state and another was the hidden state. So we have two inputs, cell state and the hidden state, and it was producing two outputs, cell state and the hidden state. And along with that, we also have the input from the sequence, from the text, right? And we are not providing the text as it is. We are converting the text into some numerical form. Then we are providing to the LSTM. So for converting the text into some numerical form, we are using embedding layer. So we have seen this in our case study as well. And this is the time step. This is same as what we have seen for our LSTM and RNN. We process one token at a time. So this is the sentence, largest ocean on Earth, and then question mark. So we'll process the first token that is the largest, and then the second token that is ocean, and so on. So this is same LSTM unit, and we are processing the all the sequence of the tokens one time step at a time. So this is just the same unit where we have rolled over the time step to show how the processing is happening. Okay. So we have the cell state and the hidden state C0 and H0. This is the initial values. So initial values are random values. Basically, we initialize some random values here and we provide to the LSTM unit. Along with that, we'll provide the embedding of the large this token that is largest. So we'll get the embedding using the embedding layer and we'll provide as input to this LSTM layer. It will produce the C1, that is the cell state from the first time step, and H1, that is the hidden state from the first time step, which again fed into the next time step. So this is the input to the next time step here, right? So this is the next time step, and here we are having ocean as the input, and we are providing this into this next time step. Okay, so this is time step 2. and this will produce C2H2, and then we'll process the next time step. This is T3, which is the word on, and similar to earlier, we'll pass through the embedding layer. We'll then pass into the LSTM unit, and along with the input, we also have the output from the previous time step. That is the C2 and H2. That is the cell state and the hidden state, and this will produce new cell state and hidden state. And this will keep going on until we process all the tokens present in the input sequence. So this is the last token that we have processed, right? This is the question mark, which is the last token. And at this time step, we provide the input question mark and then C4, H4. So this is fed into this LSTM unit. This produces this C5 and H5, right? So these are the cell state and the hidden state from this last time step. And this C5 and H5 are the context vector. So these are the context vector. And we have seen that how this C5 or H5, the hidden state or cell state, are encoding the information from the whole sequence. So that the output that we are getting from the last time step, that is the C5 and H5, will have encoded information from the whole sequence. So the information about the whole sequence, that is the summary of the whole sequence, is present in this cell state C5 and hidden state H5. So this is our context vector, and we'll provide this context vector to our decoder. So this is the encoder part that we have discussed here, and we'll see the decoder part where we provide this C5 and H5 as input. So now let's look into the decoder. Decoder is the part where we get the output. And so we, for the input, we'll provide the context vector that we are getting from the encoder. So this is C5 and H5 is the context vector that we are getting from the encoder. And this is the LSTM unit. So we'll provide C5, H5 as input through this LSTM unit. Along with that, we'll provide this start token. We'll have two reserved tokens, that is start and end. Start will start the output sequence, and end will end the output sequence. So first we'll input the start token. Here also we'll have the embedding layer because we need to convert this into some numerical form. So we get the embedding of this start token. Along with that, we provide the context vector in the first time step. And here, what will happen is that we'll have this embedding from the start token. C5 H5 will be provided to this LSTM unit, and this will produce some output. And the output is going to be a numerical form, right? And we need to convert that output, that is the numerical form output, into word. So this softmax layer is used. So you can think of softmax layer as reverse of this embedding layer, because here we convert the numerical form data into the text data. Okay, so this will so if you input the numerical form, we'll get the output word or output token. Okay, so we don't have to go deep into the softmax layer. It converts the output that we get from the LSTM or RNN units into words. Okay, so this softmax layer will convert this into the output that is specific. So this is the word that we get or token that we get in the first time steps. So this is the time step T1. Now we'll feed this T1 into next time step. Okay, so we are feeding this. So here this. So we are feeding this. Okay, we are feeding this into next time step. So this is time step 2, and we are feeding this here. So this specific is now input for the next time step. So similar to before, we'll convert the word or token into embedding. Then I will provide into the LSTM along with the output, that is the cell state and the hidden state that we get from the previous time step. So we are getting C6, H6 from the previous time step, and this is the specific, that is the output from the previous time step, and it will produce the next output, that is the OCN. Okay. So here again, the softmax layer is used to convert the numeric form into some word. So we get the output ocean. Then ocean is again provided back into this decoder unit as input, and we'll pass through the embedding layer. We'll have the steady state and hidden state from the previous time step, it is C7, H7. So both of them will be fit into the LSTM unit here and along with this embedding, and this will give us the end token, right? This is the end token. And once we find this end token, we stop processing. Okay. Here we see that we are producing one token or one word at a time step. So we don't have any fixed time step, or we don't have any fixed output size. It will keep continuing and will keep producing one token at a time and till we find this n state. Okay, n token. So this is the decoder. Basically, decoder will use the context vector to produce the output. So we saw how decoder works, but in training phase, there is a slight change in the decoder processing. Basically, we use this technique called teacher forcing. Using this technique, the model training happens faster. So this is a technique for model training, and this is done in the training phase, not in the testing phase or prediction or inference phase. In the prediction or inference phase, the whatever we have discussed is happening in that phase. And but in training phase, there is slight change. Basically, everything will remain same. What will happen is that the here, right, for this start token, the model produce Atlantic. Okay, but we know this is not the correct answer. We have the training data, and that will have the output, right? Correct output. So instead of providing this as the input to next time step, we'll provide the correct token. So that is specific. Instead of the predicted token, we'll provide the actual token. Okay. So this will help the model in training, and this will produce better model as compared to without training without training teacher forcing. So that's the change in the training phase. So this is the complete encoder-decoder architecture with all the details. These are the different time steps T1, T2, T3, T4, T5, T6, T7, and T8. Okay. So these are the different time steps. In the first part, we are doing encoding using the encoder. Basically, it's a STM unit where we provide the input sequence or input text, and it produces the context vector. And then we are providing this context vector as input to our decoder. So this is our initial state for our decoder. Okay, here we are providing this. And along with that, we also provide the start token. Then it will start producing the output, and we'll keep running this decoder part till we get the end token. Okay, that's how we know that the output is complete, and it will keep running in loop. Okay, basically it will we get the output, we provide that output as input to our unit. So here we have used the LSTM unit. We can also make use of RNN or GRA unit, and that is also going to work. And for this example, I use the LSTM unit. I hope the explanation was clear. And if you have any queries, please comment. Please like if this video was helpful for you. See you next time. Bye.